You're going to hear from a lot of vendors today, and we're all going to say the same thing, which is our solution is simpler, our solution is more secure, our solution is easier to manage. And I'm going to say the same thing. But what I want to do is I want to convince you that microsegmentation does not need to be complicated. It can be impossibly simple. And when I say impossibly simple, I actually mean one-click level of simplicity. So instead of belaboring the point in slides and yammering on, why don't I just show you? So we'll get into the details. I'm just going to give you the punchline right now. So we log in. We identify some objects here. And we literally click Auto Segment. All of those objects were built for you. A machine learning system automatically defines the objects that work together to deliver business services. It creates all of the policies to automatically segment it. In about 30 seconds, it completes that task, lays out the entire policy set in front of you, and then we will get into the details of what that is doing. It's also worth noting that the policies it's creating are identity-based. They're actually using the immutable properties of the software in cryptographic identity to make sure that it is only the right software communicating. So let's wait for the policies to fill in.
Can you explain to me what you mean by software? Because that means
we are absolutely going to get into that.
Every operating system has at least 250 different packages running?
Yep, you're right. You're right.
And I assume at some point you'll be going into, you just did one click, but what did you do before that?
We're going to get into that right now. So leading up to this, what we did was we dropped, for the Windows environment, we dropped a Microsoft-signed MSI into Active Directory to deploy it everywhere. Some of our customers do that with SCCM. We provide the instructions and scripts to do so. In the Linux environments, our customers use SaltStack, Ansible, Chef, Puppet, whatever the configuration management system is of choice.
So it's an agent that gets deployed onto all of the devices?
That is right. It's actually a Linux security module, LSM module, as well as a WFP module. And we will get into all of those details.
How do you know which policy you said it's identity-based, but how do you know which policy to apply based either on identity, and again, I have questions what you mean by identity.
Tons of interesting questions here, and we are going to get
one click.
We are going to get deep into this.
Like the one click, great, you create all these things, but I don't want to just deploy.
Of course not. And you don't want this to go into a default block. So let me set the stage here for what Edgewise is, and then we'll get into exactly what we're talking about. And it gets a lot deeper than this as well. What happens when you upgrade software? What happens when there's a load balancer in the mix? What happens when this, that, or the other thing happens? I just wanted to show you the punchline, which is this all culminates to a single click. And then we'll figure out how we actually did that. So I started the company. My name is Peter Smith. I'm the founder and CEO. Started the company in 2016, backed by really some legendary investors. Maria Serino from 406 Ventures and Jeff Fagnan from Accomplice. They're the investors behind, lead investors behind Carbon Black, behind Veracode, behind ThreatStack, behind Recorded Future. My co-founder is Harry Sverdlov. He was the chief technology officer of Carbon Black for 8 years, and really one of the pioneers of application whitelisting. Created the Bit9 application whitelisting product for the NSA under, I believe it was a National Science Foundation grant. We're based in the Boston area and really have built a stellar team. VP of Engineering was VP of Engineering from Veracode. Nagraj was from Recorded Future. Harry, of course, from Carbon Black. Just really an all-star lineup. Lots of great recognitions. We won't get into them. We'll get into how we do what we do. We call this zero trust auto segmentation. Split it in half. What's the zero trust part? Well, that's identity. It's verifying the identity of everything that communicates every time it communicates. And then auto segmentation is, of course, the ML automation that makes all of that happen. And what I'm going to show you throughout the presentation is how we eliminate attack surface in the environment and deliver what we refer to as provable security outcomes. Very simply, if you think about threats, there's an infinite number of threats, right? It grows every single day. If you think about vulnerabilities, it's an infinite number of vulnerabilities. The latest stat I saw was something like 19 CVEs published every single day on average. Networking is unique and different. It's bounded. In IPv4, at the end of the day, there's only 4 billion to the 4 billionth minus 1 possible network paths. And if you can observe them, measure them, then you can actually quantify how close to perfect protection you have. That's what I mean by provable outcomes. Immediate results, I think that's pretty close to immediate, and we'll get into exactly what that means, timescales, what the deployment process is like and otherwise. And then zero-touch management, which we will also get into. Self-updating, auto-adapting environments that use things like fuzzy hashing to identify how software upgrades and automatically apply the right policies to it. Let's jump into it. We'll cover some basics, topology, deployment, stuff like that. The topology of the solution is very simple. It's a cloud-based ML system. There's the LSM module and WFP modules that communicate up to it using secure WebSockets, MTLS authenticated. Then there's the Edgewise console. We take security of our platform very seriously. You do not get into our console without an MTLS certificate in your browser. That then gets you to the front door where you can actually authenticate to the console. So this is to prevent drive-bys of the site and whatnot. And then the last one is probably the most dry topic, but I'm going to try and spice it up for you. It's API. A very interesting way of navigating and interacting with our API that takes a lot of the busy work out of creating automations and scripts. So that is how the service is structured. Any questions on that? I want to make sure that I don't go too quickly. Great. So what is this thing that you deploy into your environment, and how do you do it? As I said earlier, most organizations for Windows will use Active Directory to cover desktops as well as servers, SCCM, as well as in Linux environments, Puppet, Chef, Ansible, SaltStack, although we don't really see a lot of that. We are an overlay. You don't actually change the underlying environment. We are not orchestrating firewalls. This is not a firewall. This is an LSM module. And what that allows us to do is something pretty interesting. I'm going to jump ahead to this guy right here. You all know this. I'm not saying it for your sake. I'm saying it for the people on the other side of the camera there. Your operating system is divided into 3 layers, right? You've got your user space, your kernel space, and then this layer that sits right in between it. It's your system call layer where a lot of the security frameworks give you access. LSM is no different. LSM gives us access right between user space and kernel space, which bestows a set of capabilities that are pretty unique. It allows us to look down into the kernel space without having to actually build very deep integrations into the kernel. So it can be very lightweight. But it gives us just enough protection where we can protect ourselves. So for instance, if you go into our system and we've got agent defense enabled and you try to kill -9 our process as root, you can't do that. It doesn't do a single thing to our process. Because at that LSM layer, we can actually look at the signals being passed into our process, trap any signal that's being sent to us, and handle it however we want. Whereas any other process, you do a kill -9, it is dead. The other thing that this lets us do is sit between the application and the operating system. So when a piece of software asks the operating system for network resources, it says, give me a socket. I want to talk to something else. We actually collect a bunch of identity properties. We get it down from the kernel level, looking through LSM or WFP, and then we compare those identity properties against policy, and policy is simply just a list of identity properties, to determine whether or not that communication should be allowed. This is incredibly fast. Now, think of it this way. We are not a proxy. We're not a layer 7 proxy. Traffic doesn't pass through us. We're looking at how software interacts with the system call layer of the operating system. And what that means is that it doesn't matter how much bandwidth or throughput you push through us, our latency is more or less constant. This set of statistics actually comes from a large SaaS provider in Silicon Valley. And what they did here to get these numbers was they took a Rapid7 scanner and they had it scan on a continuous loop 8,000 servers, each with roughly 3 to 5 listening services. So you can imagine that's a pretty big policy set to allow all of that access, and it's doing it very aggressively. Lots of new connections over and over and over. The peak latency they witnessed was 10 microseconds. Typically, what we see in a lightly loaded system is 2 to 5 microseconds. And this is because we don't actually handle packets. We don't look at them, we don't care about them. There are some edge cases where we do want to look at a packet, but we'll get into those, particular for load balancers. CPU usage, less than 1% of 1 core of CPU. Just the other day, we did a POC at a large tax provider that was doing Commvault backups. They set all of their backups to go, and the max CPU usage they saw was 0.1% with very high throughput. Memory, very small footprint. Again, this is a compact set of identity properties that are sent from the ML engine down to the endpoint to do its enforcement. The policy set here was under 10 megabytes, the largest we have seen in practical situations with tens of thousands of systems is 12 megabytes. And then secure boot sign by Microsoft so that we can install, update, and remove without any reboot ever, even in secure boot enabled environments. And that applies for both Windows and Linux. Never have to reboot.
The
So,
bandwidth.
question.
Yes.
What you have, you said properties.
Yep.
Are
That is literally the next
properties
slide.
Are you talking about?
Yep.
Because there's 1,000,001.
Yeah, you got it. Let's do this. So we use properties. We call it zero trust identity, buzzy, for 2 reasons. One is to build these identity-based policies, and the other is for the machine learning engine. So what are these properties? The properties are SHA-256, LSH hash, PE headers, which instead of enumerating all of the possible properties of a PE header, I just put PE header. That would include signing certificates. It would include version information, original file names, so on and so forth. We use process identifiers that you would expect, like PIDs and stuff like that. The big difference, though, here, and I really want to impress this upon you, is that our solution does not look through the proc file system. I mean, that is just trivial to manipulate. If you are in user land looking through proc to get identity information, you are not getting identity information. You're getting whatever somebody wants you to see. So we collect these properties, fully compatible with containers. We ourselves are a Kubernetes environment with Docker under the covers. We protect ourselves with our own service. So we support anything that is Dockerized, including Kubernetes and Mesosphere. I'm sure there are others that would work. I've just not encountered them. And then on the host, we uniquely identify virtual infrastructure as well as physical hardware, of course, using those serial numbers of CPUs, UUIDs of BIOS, so on and so forth. We collect all of the network information for end-to-end communication paths as well. And then we run all of this identity information through, in this case, software reputation is VirusTotal. Then behavioral scoring is our own internal analysis by the ML engine. And then the last one, which is something that you've probably never heard of because we made it up, capabilities classification. So capabilities classification is kind of an interesting problem space. You've got fixed function, single-use software, multi-use software that is like an administrative tool. How do you determine which is which without having a list beforehand? Well, what if I took a piece of software and I watched how it was used by administrators and people? Let's take Microsoft Dynamics as an example. And what we do is we see that user instantiated it with these command line arguments, they upgraded it, they changed the file, they passed it a different set of options, and every time they manipulated how that system functions, it always talked to that MS SQL server over there. That's all it ever did, was talk to that MS SQL server over there. Versus the MS SQL admin command, which every time it was instantiated with different options, arguments, files, otherwise, it talked to this guy, then it talked to that guy, then it talked to that guy. The reason for capabilities classification is to understand, is this software that does a lot of different things at the will of the administrator? Or is this something that does a fairly narrow set of functions independent of how it's instantiated or used? And the reason we do this isn't really to raise a flag to you. It's not really for you. It's for us to figure out whether or not we should give broader or more restrictive access. It's for us to figure out, is there high potential for abuse? And if there's high potential for abuse, then we should give it a more least privileged policy set. If there's low potential for abuse, it's perhaps counterintuitive, but you actually want to give it a little bit more access. The reason is this: we don't want you to have to make administrative changes. If I can tell you that it is actually Microsoft Dynamics communicating, I can verify that. I can give it access to things that it might not actually today need access to, so that when changes that are legitimate, like auto-scaling, like just ephemeral changes in your environment occur, we can make sure that at the end of the day, you know what, there's a new Active Directory server that just spun up, and this Microsoft Dynamics app talked to the LSAS process. It's never done that before. Do you want to have to go make an administrative change to allow that? Of course not. But the reason that we feel that it is safe is because we know that it's actually Microsoft Dynamics talking to this new instance of LSAS, which we know to be LSAS. So we're allowing this sort of expansion of access based on those identity properties. Please.
Thank you. Couple questions. You say BIOS, UUID, and CPU serial numbers and provision hostname and all that. Well, in a virtual environment, I can duplicate those any number of times I want to.
Yep.
So I find those kind of useless.
It depends on your perspective. So from the attacker's perspective inside the machine, you're taking it from the mindset of an administrator. An administrator can change a configuration file to mimic and duplicate those objects. And if the attacker is in your, let's say, vCenter, you've got different problems that this doesn't quite
Problem is, even as
target.
an attacker, I attack administration more than I attack the guest. In a virtual environment, where that's usually what happens. I can
absolutely agree. And we protect the front door to those tools as well.
They should be. But those attacks still, that vector still exists. I can make all my virtual machines look like the same fingerprint. So I don't know how you defend against that inside of your tool. The other one is you say network namespace. Please explain what you mean by your namespace, because what I mean is totally different.
I mean the Docker implementation of namespace separation between containerized objects. So this is when I say network namespace in this world, it's actually linked back to this.
Thank you.
Yeah.
So
also LSM has a concept of network namespaces.
So address and port, well, address is usually kind of address MAC. I can duplicate those as well, so you would never know which one's which.
That's not what this is informational collection. So this is the list of attributes that we collect from the system to do our analysis.
But if I'm duplicating a lot of your base assumptions, and part of it, how do you know which object is which object that you're trying to protect against if I have 2 different objects or even 20 different objects in my environment that all look the same?
Yep.
That's a problem.
And that is actually a key indicator and signal of a problem, which from a remediation perspective and a response perspective, that is an actionable event.
You
should
that
definitely
as an action.
Anytime there is an identity change. So let's just...
Identity collision? You raise an action on an identity collision.
Whenever identity changes or whenever a new system comes into the environment and has different properties that are not expected, they're all put into these event types here. So that would be declared a host event type. versus an enforcement event type versus an application. This is for actually somebody manipulating identity of software. So if I come in here and I say last week, for instance, these are similarity events where this software was updated. These are all legitimate changes for similarity. If I were to, let's say, take the netcat command and rename it, or append some garbage to it, run it through some manipulation, and rename it to Python 3.4, what you would actually see in here is an event that says, this is a new application that is not similar to this, despite the naming. And so there's a good example of this. I'll have to find it.
How do you raise this as an alert that I can now act upon? Because I'm
another great question.
My main concern is that I'm not going to be using your dashboard, or I may not be, or my security people may not be, and I'm not going to want to download anything.
Let's do this. So your SIM does imports of JSON objects. So what we do is, this is for you to download, but there's also, so you literally say, this is the type of attributes I want. You say download the log. This is a pre-authenticated S3 link, which allows you to get access to that specific blob of JSON data. Now, if you want to do it in a more programmatic way, this is much more interesting. So we're going to go into API here. We're definitely jumping around, so bear with me. We've taken a slightly different approach to APIs. So let's say I wanted to know about, I'm going to do a simple one that is just conceptually easy. I want to know about agents in my environment. So what I do here is I say, I want to know about agents, and I want to know every instance of them. What I want is the friendly name, the full name, the health status, the operating system, and what time it was registered. And what I'm going to do is just click play here, and so there's my result set. Now, what I realize here is what I wanted was for this to be ordered by something different. I want it to be ordered by operating system. So I can say order by, and I say operating system in ascending order, and I click play. Now, once I'm satisfied with how I model this data, it could be UUID information, it could be host identifiers, it could be this is the full API on the side. So you've got where are the audit events? Audit events. So there's a full set of audit eventing here. So I figure out the structure that I want. I'm done. I'm satisfied with how it's modeled. I can see all of the results here. Literally what I do is I copy this and I paste it into, I think I have a shells. Oh, I deleted it. Never mind. So we've got shell wrappers that you can just simply copy and paste these into. And now I've got that in my script that I can do any administrative action on. So you've got two options. And you can also go to the API and say, get me all of those S3 bucket JSON object links. So that instead of being a user and saying, click, get the JSON blob, and feed it into my SIM or do analysis on my local system, you actually programmatically do that. You say, get me the latest S3 bucket dump. There it is. Slurp it into my SIM with whatever import process you want. You can do it directly through this if you want. And the last thing I would point out is, there's a lot to interacting with APIs. There's modeling your data, there's doing the queries, there's putting it into your framework, there's getting access. So you click headers, and there's your authentication token that you copy and paste into your script. If you've got questions about what any of this does, you want to know about audit, sure. Audit event source. There's your documentation in line, in the product, alongside the entire API that you can click through to model out queries, copy and paste into your script, take your authentication token, and you're off to the races. So you can get this data however you want, and you don't have to do it by futzing around in your scripts. You model everything and drop it into your integration.
Is there already an audit event for collisions?
What's that?
Is there already an audit event for collisions on your...
There is an audit event for everything.
Okay.
Literally everything. If you make a user, there's an audit event. If you provision a new host, there's an audit event. If you have a similarity event, there's an audit event.
I have a question. Not in the lines of what they're doing, actually more in the lines of when working with an organization, because this looks quite complex, which is awesome. But the one thing I've noticed when it comes to running with other organization and training in that, the one challenge I've really had, for example, just using Splunk, because again, that's really complex. How do you effectively treat the whole training of using this software? Do you have certifications that people can go and get, or is this more of a, because I know that Rapid7, just again as an example, they have their own, you buy the product and then you also get hands-on training. Do you do something similar to that, or is it more of a, you guys configure it and then go away?
No, we don't configure anything. And in fact, when we go into environments, we do the deployment offline. It's actually the end user that does it. We give them the scripts to automate the deployment out to their systems. The system requires around 72 hours. It depends on if you put us into a lab that just has really no traffic, or if you put into something that's pseudo production.